settings. Pleasures, objects, poses, symbols of prestige, gestures, signs of love. To be in two worlds at the same time, just where Europe ends.
Toward the end of the terrestrial 20th century, scientists from the second planet of the star Epsilon Eridani set out to classify living organisms in remote sectors of the universe. These are the stories of those explorations and of the brave beings and robots who made them possible.
The pond, a teeming microcosm of freshwater life. Each cubic meter of water is home to thousands of tiny invertebrate animals. These organisms feed upon an even smaller assemblage, the microscopic algae which live in the open water of the pond. The bottom sample is composed almost entirely of nitrium, a large unicellular alga. Organisms such as nitrium are extremely important in the ecology of lakes and ponds. Through photosynthesis, these microscopic producers convert light energy into food which is passed on to the communities of animals which live in fresh water.
We're at the beginning of a new wave of research. Our creative powers are being stretched. We're learning surprising things about how we sense the world around us. Exploring the mysteries of the spoken word.
Nice. Nice.
Noise, noise, noise.
noise, 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 noise.
Under computer control now, the taped information is converted into rapidly moving pictures made up of a fine mosaic of points of varying light intensity. A synchronized movie camera automatically photographs the fast-moving images as they are plotted and drawn on the face of a cathode ray tube.
I want to reach out to this technology. I want to incorporate this technology into my art and have the two mixed together. For instance, what spellbinds me as an idea is that I'll be able to sit someplace in a railroad station and write a movie, or maybe even pick up a telephone eventually and write a movie.
Besides creating unique visual effects, computer movies can be used to show phenomena we can't directly see. This film describes the motion of a communication satellite. By studying it, scientists can obtain new insight into the satellite's stabilizing system. Only a man orbiting alongside could observe it the same way. Experimenters in visual perception are using computers to create weird, random patterns that never occur in real life, to find out what and how people see when these patterns are shown to them. The shape and texture of perceived objects are studies that look deep into the future of communications. When we learn to separate the relevant from irrelevant in visual information, we'll be on the way to sending three-dimensional color picture messages over ordinary telephone lines. What actually happens when we hear sounds?
To be or not to be? That is the question. Whether 'tis nobler in the mind to suffer the slings and arrows of outrageous fortune, or to take arms against a sea of troubles, and by opposing end them, to die, to sleep.
Once we believed the Earth was flat and that the sun revolved around us. Today, we believe we are the only creatures on Earth with a mind and soul. But maybe we are not the only ones. Maybe there is another such creature. Dolphins are mammals, warm-blooded, air-breathing. They are found in all the oceans of the world. They give birth underwater to live young who must swim to the surface to breathe. Dolphins seem to have had a very important relationship with humans in ancient times. The oldest known painting of dolphins, some 4,000 years old, is found in the Queen's Chambers at Knossos, Crete. In ancient Greece, the dolphin was revered as a god. Aristotle studied the biology and behavior of the dolphins and wrote, "They care for man and enjoy his music." About 65 million years ago, ancestors of today's dolphin walked the earth. The first of these creatures to enter the sea had webbed feet and nostrils at the front of the head. Gradually, the fingers fused into flippers, and the nostrils migrated to the top of the head as the dolphin evolved into a totally waterborne creature. What forced the early dolphin back into the sea is unknown, but its land ancestry is still visible in the flipper, which was once a hand. Unlike humans in sleep, the dolphins rest one half of their brain at a time, closing one eye while the other remains open on the lookout for danger. Every 20 to 40 seconds, they surface to breathe and alternate eyes. The total accumulated sleep for dolphins is about 2 to 3 hours per day. Dr. John Lilly, a pioneer dolphin researcher, discovered that the brain of the bottlenose dolphin is 30% larger than the average human brain, and every bit as complex. Humans have had their large brains less than 1 million years. Dolphins have had their large brains perhaps 30 million years. The puzzling question is, why would the dolphin develop such a large brain unless it was doing something quite extraordinary with it? When such facts became known during the 1950s, the U.S. Navy began experiments with dolphins to find ways of putting them to use in dangerous and difficult tasks underwater. Steve hopes the music will bring the dolphins closer to him.
The keyboard is not that easy to play underwater. Between my breathing and trying to swim and controlling my buoyancy, I was having trouble making music.
They sonar me continually. It feels like bubbles tingling in my spine and at the back of my head.
Steve plays melodies, chords, and tries to imitate the dolphin sounds. He does his best to match their swimming motions. He hopes that by playing the piano underwater, the dolphins will be able to determine how the sound is being made. The dolphins slow down almost to a stop to be with Steve and his music. After this scouting party of dolphins, some 50 others begin circling the boat. Steve returns to the Albury as other divers enter the water.
I just started swimming down and swimming with them. There's a real sense of kind of a ballet or a dance taking place.
I want to share with you some of the things I've learned. Whether it's materials handling or a relatively simple pick-and-place application. Or the most critical vision-assisted assembly task. Or machine loading. Or welding. All kinds of welding. Or soldering a tiny circuit board with watchmaker's precision. Or laser beam cutting. Or a TV-monitored multi-stage inspection process.
A chemist takes the world into the laboratory to probe the elements of change. but the metal most prized for its luster, its malleability, its resistance to rust and corrosion was gold. It was the quest for a way to change other metals into gold that gave rise to the magical art of the Dark Ages, alchemy. In secluded, smoke-filled workshops, the jealously guarded secrets of the alchemists were practiced and elaborated. Men sought a universal, perfect principle, to purify life by freeing it from disease and death, to purify matter by elevating it to gold. The precious metal itself was fairly readily purified, for it is not very chemically active. Simply heating impure gold in a porous crucible will cause the impurities to be absorbed by the substance of the container, leaving a shining globule of molten gold. Alchemy was not a true science, but only haphazard experimentation. However, in the alchemists' workshops, there grew a useful body of knowledge about various substances. It could be demonstrated, for example, that if a red powder called cinnabar is heated, it will produce the silvery metal mercury. The alchemists considered mercury as a symbol of one of the same ancient elements: earth, water, air, and fire. This alchemist, Hennig Brandt, actually isolated what modern chemists would call an element, phosphorus, one of the 100 or so substances from which all other materials are formed. The chemist, measuring weights and energies, today studies how the elements combine and what they produce. Prediction and control of chemical change depend on knowledge of how the reacting substances are structured. Conversely, carefully observed chemical changes helped reveal the structure of matter in the 18th and 19th centuries when modern chemistry was born. Rust is the product of the slow combination of iron and oxygen. With red-hot steel wool, iron combines with oxygen fast enough to burn. Fire releases energy in the form of light and heat, energy that could be converted into motion. In this age of nuclear power, man has begun to harness the energy released by another kind of change within the atomic nucleus itself. Early chemists were wrong. The atom can be split. Chemistry has now produced many drugs by extraction and synthesis, each with specific effects on the body or the mind. LSD. This is the plan of the molecule that has such a drastic effect on the human brain. But LSD's hallucinogenic properties can be eliminated by one minute change in its molecular structure, the addition of a single atom of bromine. Slight changes in molecular structure can produce extreme changes in chemical property. The green pigment in plants, chlorophyll, has a molecule like this, with magnesium at the center. There are certain crabs whose blue blood contains a substance with a similar molecular structure, with one small difference. The central magnesium atom is replaced with an atom of copper. The same molecule will form the hemoglobin in our own red blood, with the substitution of an atom of iron. Chemists can produce substances that are usually manufactured only by living tissues, and some people wonder if chemistry might not someday be able to reproduce life itself.
Movement. Most movement we're aware of is organized, orderly, and follows definite paths. In contrast, the movement of these beads is unorganized, random. Random movement is typical of very small particles, such as smoke. In these experiments, diffusion of molecules is indicated by the spreading color. Plants use the force of osmosis in many of their life processes. In animals, too, many essential functions depend on diffusion. A fish obtains oxygen through its gills. Oxygen diffuses from the air into the blood.